Okay, so here we are with lesson 27, the laws of exponents. Objective 1 is to use the laws of exponents. So first thing we know is we're going to talk all about powers again. So remember powers, we've got two different parts. Remember what those are? This one's called the base. Okay, the big number is the base. And the small number is called the exponent. Okay, so today we're going to talk about some rules for these guys, these exponents and the bases. Okay? And just a quick reminder to remind what this means. This means that I'm taking the number 3 and multiplying it together 4 times. Okay? Alright, let's move on to our laws of exponents. Okay, so the first law we have is called the multiplication law of exponents. Alright? And what we're going to do here is we're going to take 2 squared and multiply it by 2 cubed. Okay, 2 to the second times 2 to the third. Let's write that out in expanded form. 2 to the second is 2 times 2. And we're multiplying that by 2 to the third, which is 2 times 2 times 2. Alright, and another way to write that is we got a base of 2. And then how many of them do we have? We have 1, 2, 3, 4, 5. So that's the same as 2 to the 5th power. Okay, 2 times 2 times 2 times 2 times 2 is 2 to the 5th power. So let's look at what we did here. Alright, our exponent law. The problem we started with was 2 squared times 2 to the third. And what we ended up with was 2 to the 5th. So we took these two exponents, and 2 plus 3 is 5. So we added them together. Okay? So 2 squared times 2 to the third is equal to 2 to the 2 plus 3, or 2 to the 5th. Okay? When we write it in simplest form. So the multiplication law says when I take a power and multiply it by another power that's got the same base, so our 2's are the same, I just add their exponents together. Okay? So let's look at example 1 down here. Example 1 says find the missing exponent. Well, we can do this one of two ways. We can multiply this all out, so I've got x to the 5th power. That means x times x times x times x times x. And I'm multiplying that by x to the third. Well, my base is x, and then my exponent is how many of them are there? There's 1, 2, 3, 4, 5, 6, 7, 8. So it's x to the 8th power. Okay? Or we could do this a simpler way, the nice easy way that we just learned up here. The exponent law is when we take a base raised to a power and multiply it by the same base raised to the different power, we add the exponents. So that's x to the 5 plus 3, which is x to the 8th. Okay? So our missing exponent is 8. X to the 8th power when we use the multiplication rule. Alright, let's talk about the division rule now. Okay, so for the division law of exponents, here's an example problem. X to the 5th over x squared. Well, in expanded form, that means x times x times x times x times x over, then x squared is x times x. Well, we could go ahead and cross out what's in common on top and bottom, like we did when we did the prime factoring and simplifying fractions. And if I do that, on top and bottom I got an x and another x. So what I'm left with is what's on top. And that's it. I'm left with x to the 3rd power. Okay? Because I've got 3 x's on the top and 1 on the bottom. Okay? Or there's nothing left on the bottom. So there's no more bottom number anymore. We got rid of it. Okay? No more expression on the bottom. So let's look at our exponent law then. Let's write down the problem we started with. X to the 5th over x squared. Well, what did we do? We took our base x and kept it the same, we got x's and still x. And then look at what we did, okay? 5 and 2, how do we go from 5 and 2 to get 3? Well, we take 5 minus 2, and that gives us 3. So this is x to the 5 minus 2, which is x to the third. Okay? So the division exponent law says when you're dividing the same base, okay, so we've got our base is x, we just subtract the exponents. So x to the fifth divided by x squared is x to the 5 minus 2, or x to the third. Alright, let's look at example 2. Again, we could write example 2 out in expanded form first and have 3 times 3 times 3 times 3 times 3 on the top. And on the bottom have 3 times 3 times 3. And then we could cross out what's in common. We're left with nothing on the bottom, and on top we've got 3 to the second power, 3 squared. Now if we wanted to save ourselves some time and not write all that out, we can use the exponent rule that we just learned, the division rule, where we keep the base and we subtract the exponents. Okay? Either way, those work. And I didn't mention this on the last slide, and I haven't mentioned it yet on this one, but I shouldn't have to anymore, but I'm going to remind you anyway. This is the kind of work I expect you to show here. Okay? So on this example, I would expect you to rewrite the problem, then show me the exponent rule. So we're doing 3, and then we're subtracting 5 minus 3. And then show me what the answer is. 3 to the 5 minus 3 is the same as 3 to the second. Okay? You could show this work, but I prefer you to use the exponent rules, means you've been taught them. Alright? Okay, let's go on to the last rule. Okay, the last rule is called the power of a power law of exponents. And the reason for that is because in here I've got a power, and it's raised to another exponent. So it's a power of a power. Well, let's think about what this means. Okay? This means 2 squared times 2 squared times 2 squared. Okay, because it's 2 squared to the third power. So I've got 3 sets of 2 squared. Well, let's break that down more. That means it's 2 times 2 times 2 times 2 times 2 times 2. Well, if I want to simplify that, there are 1, 2, 3, 4, 5, 6 2's. So that's 2 to the 6th power. Alright, so now let's look at my exponent law. 2 squared to the third power, we ended up with 2 to the 6th. Okay, so what did we do with our exponents here? How do I go from 2 and 3 to get 6? I multiply them together. Okay, so 2 squared to the third power is the same as 2 to the 2 times 3 power, which is 2 to the 6th. So our power of a power law states that when we got a power raised to an exponent like this, we multiply their exponents together. Okay, let's try this in example number 3. Again, we could write this in expanded form. This is x to the third squared, which means x to the third times x to the third. And if I write that out more, that's x times x times x times x times x times x, or x to the 6th power. Okay, that's one way you could solve it. But let's use the quicker way. So first thing I want to do, I'm going to use our exponent law. First thing I got to do is rewrite the problem. Okay, then I'm going to show our exponent law says we're going to take the exponents and multiply them. So I'm going to have x to the 3 times 2 power. And that equals x to the 6th. Okay, again, this here is the work you're showing me. Rewrite the problem, show me you're multiplying the exponents, and then give me an answer. Alright, let's do one more set of stuff. Alright, this says write each expression as a power of 10. Okay, so this is what we've just done. Now let's look at this example right here, and first of all we're going to rewrite it. This is 10 to the 8th times 10 to the 6th. This is an example of a problem why the exponent rules are nice. Because I could write out 10 to the 8th, 10 times 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 10, and then multiply that by 6 tens. 10 times 10 times 10 times 10 times 10 times 10. Well, that's a lot. Okay, or we could just use our exponent rule. This is the multiplication exponent rule. Okay, I'm taking two powers and multiplying them together. So the exponent rule says I keep my base the same, and then I add the exponents. So it's 10 to the 8 plus 6th power, or 10 to the 14th. And there's our answer, written as a power of 10. Power of 10 just means I've got a base of 10 raised to some exponent. Alright, let's try B. I got 10 to the 8th divided by 10 to the 6th. Again, I don't really want to rewrite out all this in expanded form, so let's use the exponent rule. This is the division rule, which states when I divide two powers that have the same base, I'm going to subtract their exponents. So it's 10 to the 8 minus 6th power. And 8 minus 6 gives us an exponent of 2. Okay? Now I could say that 10 squared is 100, but this asks me to write it as a power of 10, so I'm going to leave it alone. This is what a power of 10 looks like. So instead of writing 100, I'm going to leave it as a power with a base and an exponent. Alright? If you got any questions on these rules, ask. Otherwise, good luck on the homework.